9.4 applications of similar triangles. It says, let me enlarge this a little bit so it's easier to see. You are visiting the Unisphere at Flushing Meadows Corona Park in New York. To estimate the length of the stainless steel model of Earth, you place a mirror on the ground and stand where you can see the top of the model in the mirror. Use the diagram to estimate the height of the model. Explain why this method works. So if you look here, right here's where your mirror's at, and the angle that you can see the top of the Earth is going to be the same angle that you're looking down. And if you notice, those two angles are marked congruent. Okay. Also, this is a 90-degree angle from the vertical line here, the height of the Earth and the ground. That's a 90-degree angle. And whenever you stand up straight. You are standing vertically and the ground's horizontal, so you're also at a 90-degree angle. Well, since those two sets of angles would be congruent, these two triangles are similar. So you can use what we've been doing to figure out the height of the Earth. So how have we been finding missing lengths of triangles? What do we do? Perfect. So we set up a proportion, and the height of the Earth, corresponds with our height. And then the distance from the Earth to the mirror, that side corresponds to the distance from the mirror to us. Okay? All right, so now we solve this. All right, so Bailey, what would be my first step? Cross multiply, yeah. So we do 4 times h and 5.6 times 100. All right, Abby, what's 4 times h? 4h. Equals, and Natalie S, what's 100 times 5.6? Perfect. And Grace, now what do? Divide both sides by 4. And then I get h equals what, Sydney? 140. So this tower of the Earth is approximately 140 feet tall. Okay? Because you wouldn't want to actually try to measure that. So you could use this method to figure out the height without actually having to measure it. And then I already explained why it works whenever I showed you how these two angles were congruent and those two angles. And if two angles in a triangle are congruent to the other two angles, then I automatically make them similar. Because third angle theorem makes these two congruent, and we already know that all 3 angles in similar triangles are congruent. Okay. All right, let's try the next one. In the diagram below, a large flagpole stands outside of an office building. Marquise realizes that when he looks up from the ground, 60 meters away from the flagpole, that the top of the flagpole and the top of the building line up. If the flagpole is 35 meters tall and Marquise is 170 meters from the building, how tall is the building? So if you look at the picture, you have 2 triangles. You have the triangle made from the flagpole, and then the distance to Marquise, and then you have this side, which represents the path from his eyesight to the top of the flagpole. That's one triangle. Then another triangle is the height of the building, the distance from the building to Marquise, and pretend that that's a straight line, and then the path from his eyesight to the top of the building. Okay. All right, so to make sure that 2 triangles are similar, you have to show that 2 angles are congruent. Well, they share an angle, so it's congruent to itself. And then the other angle that's congruent, there's a couple here. This one's a 90-degree angle, and that one's a 90-degree angle. So both of those are congruent. Also, his eyesight is going to be the same for both, so these angles would be congruent to each other as well. Okay, so those two triangles are similar. Since they're similar, you can set up a proportion. You got the height of the flagpole, which is 35, and the height of the building, which is h. So those are corresponding. You have the distance from Marquise to the flagpole, and then you also have the distance from Marquise to the building. Okay, so we need to set up a proportion. Natalie B. Bowen, how would I set up that proportion? Or how would you set up the proportion? Okay. Well, you pick the corresponding sides. Okay, so which side of this triangle do you want to pick, the 35 or the 60? Okay, so that's the distance from Marquise to the flagpole. So is that going to correspond to the H or to the 170? 170. Yeah, the 170, because they're both the bottom parts of the triangle, so they're corresponding. So you would do 60 over 170 equals, now set up your other proportion. What would the other side look like if you did 60 over 170?
35.
It would be 35 over H.
For the 170, would you do 170 minus 60?
No, because you're doing the entire distance. Now, sometimes they would only give you, if they only gave you, say, 110 from the flagpole to the building, then you would have to add 60, because that wouldn't be the entire side of the triangle. So you do have to be careful there. All right, so now we solve it. Maddie, what would you do first to solve this?
60 times x and 170 times 35.
Perfect, so 60h equals, what's 170 times 35?
5,950.
5,950?
Mm-hmm.
Okay. Now what would I do, Natalie, the other Natalie B?
2 12,000 divided by 60.
Perfect. And what's 5,950 divided by 60?
99.16.
Okay, and does it, you said 99.16?
Mm-hmm.
All right, so let me see if it asks us to round. It says if the flagpole is 35 meters tall and Marquise is 170 from the building, how tall is the building? Okay, so we're going to say that's really close to 99 feet. So I'm going to say that the building is approximately 99 feet. If you put 99.16, that's fine, because they didn't tell us to round. All right, so now that we've done 2 problems, what questions do you have for me? Number 3. Katerina's boat has come untied and floated away on the lake. She is standing atop a cliff that is 35 feet above the water in a lake. If she stands 10 feet from the edge of the cliff, she can visually align the top of the cliff with the water at the back of her boat. Her eye level is 5.5 feet above the ground. Approximately how far out from the cliff is Katerina's boat? Okay, so first you got to figure out your 2 triangles. Like, which ones are your 2 triangles? And so where are my 2 triangles at?
The 5.5 and then 10 and then like draw that, you know.
Okay, so there's one triangle. Now where's my other triangle? And which side am I trying to find the length of? Pretend like that's a straight line and it follows the path. Yeah, so I'm trying to find that length right there. Okay, so since they're similar, and how I know they're similar is because this is a right angle, and when I stand up, I make a right angle with the ground, so that's a right angle. And also it says her eyesight goes from here to the top of the boat. So this top angle here would be congruent to this top angle here because of eyesight. So your eyesight, it doesn't go like this and dip down, your eyesight goes straight forward, wherever you're looking at. So I know they're similar, so I can set up my proportion. All right, Taylor, how would I set up my proportion?
X over 10.
Okay. X over 10 equals,
35 over 5.5.
do y'all agree with that? Okay, so he did the bottom over the bottom equals the side over the side, and he did the boat to the person on both of them, so it's perfect. All right, Bailey, what do I do next? Cross multiply, perfect, so we get 5.5x equals, Lincoln, what's 35 times 10? Okay. And Natalie B, our Bolin, what do I do next? Yep, so we're gonna divide both sides by 5.5. And what do we get that x equals?
0.015.
Do 350 divided by 5.5.
63.64.
So that's approximately 64 feet. So it's approximately 64 feet away from the cliff now. And that's something good to know, like if you're having to call them and say, hey, my boat got untied, my boat's untied and it's floating away, it's 64 feet away from the cliff. So that means it's traveling at this rate. So that means by the time you get out there to get it, it's probably gonna be this amount of feet away. That way because they're not gonna come to that 64 feet. They're gonna try to determine where it would be at.
I always second guess myself with it before you guess.
Yeah, a lot of, like, every time someone got that 22.5 yesterday, I think that's because, like, in most of our problems, teachers try to make it to where you always get a whole number. And in real life, very rarely do you ever get a whole number. It's usually a decimal. Or whenever you get in upper level math classes, it's usually a fraction or a decimal. You hardly ever get a whole number.
Like chemistry, and if I use sig figs, it's just kind of.
What is it called?
Sig figs?
Sig figs is that,
My sister told me about those. It's terrible.
Okay, here's something like what we're going to be doing on Monday. And I need to get my pen and make this smaller. It says find the height of the tree. So what it is, you have a person that's 5 foot tall and their shadow is 7 feet. And then you have a tree that's X feet tall, but their shadow is 14 feet. We're trying to find the height of the tree. Well, first you want to make sure that the two triangles are similar. The first thing, whenever you stand and whenever a tree stands, usually it makes a 90-degree angle. There's a tree in front of my house that's actually leaning toward my house, so it's not a 90-degree angle. And whenever it casts a shadow, the sun casts a shadow, and the sun is coming down at this, if you're standing beside, if y'all are in the same location, the sun is hitting y'all at the same angle. So, like, if you and someone else is standing beside, the sun's going to be hitting y'all from the same angle. So, like, y'all would get, like, a sunburn on the same side. Your shadows would be going in the same direction. Okay, so these two angles at the top would be congruent. So, these two triangles are similar. So, now what we need to do is find the height of the tree. Brett, how would you tell me to do that? What should I do?
X over 5 equals 14 over 7.
X over 5 equals 14 over 7. So he took the height of the tree over the person's height equals the shadow of the tree over the person's shadow. Okay, so you have to make sure you keep the corresponding parts together. All right, Taylor, tell me what to do.
7x equals 7. Divide by 7.
So 7x equals 70.
You divide by 7 and you get 10.
Now, does it make sense that the tree's height is going to be less than its shadow?
Yes.
Why?
I don't know if that works. Correct.
Science.
Correct.
Well, if you look at the person, it's not going to happen all the time, but if you look at the person, their shadow is longer than how tall they are. So it makes sense that this number is going to be bigger than that number. Okay. Now, sometimes whenever the sun's right directly on top of you, your shadow is really, really small, and sometimes it's like just around you. All right. What questions do you have on applications of similar triangles? Okay. This is the next page of your notes, page 44, I believe, and it's 9.4 applications. Now, Monday, if it's sunny, it has to be sunny for us to be able to do it. We are going to be going outside, right out here, and we are going to be trying to figure out how tall this telephone pole is that's outside my classroom. So we can only do that if it's sunny.
It's supposed to be like 80 degrees Monday, so it should be.